Good morning. I am Denise Yarbrough. I am the Director of Religious and Spiritual Life here at the University of Rochester, and I'm delighted to welcome all of you who are here in the room and also those joining us via the live stream to the 4th Annual Judith Johnson O'Brien Endowed Lecture. Presented yearly by the Catholic Newman community of the University of Rochester and this year co-sponsored by the Interfaith Chapel, the purpose of the O'Brien Lecture Series is to bring to the university community knowledge by a distinguished scholar about women in the Catholic Church, or broadly, women in the world's religious and spiritual traditions. Before we introduce this year's O'Brien Lecture presenter, we would like to express our gratitude directly to those who have supported and financed this lecture series, namely University of Rochester President Emeritus Dennis O'Brien and his wife, Judith. This morning, they are joining us via the live stream, and we are forever grateful for their support of this lecture series and of overall Catholic life and its intellectual tradition at the University of Rochester. The Interfaith Chapel is grateful that they support this kind of programming, which lifts up the intellectual prowess and contributions of women. We at the Interfaith Chapel often present programs that illustrate the important connection between science and religion. On a heavily STEM campus like the University of Rochester, we who practice various religious traditions often find ourselves having to explain to our secular colleagues that being religious people does not mean that we do not believe in or respect the wisdom offered through science. So I'm particularly delighted today to be able to introduce to you Dr. Michelle Frankel, who will speak on the topic, Coding the Universe, What God Has Written for Science to Read. Dr. Frankel currently serves as the Frank B. Mallory Professor of Chemistry at Bryn Mawr College, where she has taught since 1986. Appointed an adjunct scholar of the Vatican Observatory in 2016, she is a quantum chemist who has developed methods for computational chemistry and studied topologically intriguing molecules. In the non-science world, she is most well known as the author of Steeped, The Chemistry of Tea, which has made global headlines and sparked a considerable transatlantic tea controversy upon which the U.S. Embassy in London and the State Department were compelled to comment. The controversy arose out of Dr. Frankel's recommendation to add a pinch of salt when making a cup of tea to reduce the tea bitterness, shocking traditional British tea drinkers. I remember thinking when that news on the controversy erupted that my British mother and grandmother were likely spinning in their graves at the mere thought of salting the tea. Dr. Frankel also writes about spirituality, often exploring the balance of a contemplative life in a chaotic world. She frequently discusses the intersection of science and religion, the key theme of her talk this morning. Believers from many religious traditions have found in science a path to God. In the Roman Catholic tradition, thinkers such as St. Anthony the Great, André Marie Ampère, and Roberto Busa, S.J., whose work helped lay the foundations for AI, are among them. Has God coded the universe to reveal the divine face? How can we find God in the created world as well as in our laboratories? We're about to learn more through Dr. Frankel's work. So now please welcome Dr. Frankel as she offers her unique perspective on how the universe might be a divine code waiting to be deciphered.
So I want to thank everyone for coming. I want to thank Father Kuhl and the Newman Center for this invitation. I want to thank for that lovely introduction. And I'm not going to talk at all about that tea controversy, but if you search my name and that online, you can discover that it was a bit of a diplomatic incident and totally unexpected. So here I am in my laboratory, and there is some laboratory glassware. And I want to say that scientists, I think, are a bit like poets. So Wendell Berry is a poet and says here, there are no unsacred places, there are only sacred places and desecrated places. Everything, in fact, is a sacred space. And chemists and scientists are like poets. We're digging into the universe and trying to wrap words and equations around things that are at infinite and perhaps at some level unknowable. So this advice from poet Wendell Berry might be apt for scientists too. Our labs are sacred spaces, as sacred as our churches, although in different ways, and we would do well to remember that. So here's a quote from Laudato Si. So this is Pope Francis quoting Ali Al-Qawas. "Prejudice should not have us criticize those who seek ecstasy in music or poetry. There is a subtle mystery in each of the movements and sounds of this world. The initiate will capture what is being said when the wind blows, the trees sway, waters flow, flies buzz, doors creak, birds sing, or in the sound of strings or flutes, the sighs of the sick, the groans of the afflicted, and I might add what's happening in our laboratories. God has left signs and symbols for us to read everywhere we turn." So coding the universe. This is literally the genomic code for a virus. It's just a series of molecules that are all strung together into DNA. But if we think about what's in every living creature on Earth bears this kind of code. And we can pull from this imagery, if we read the Psalms, they talk about bees and snail slime. All of that is all coded in the same code that we are coded in. But there are other codes. There's codes for inanimate things. We hear in the Gospels, even the stones will cry out. So the stones have something to say for us about creation. So this is tourmaline, and I picked this one to show, and there's its molecular structure shown in two different ways. If you could see into tourmaline, this is what you would see about the arrangement of atoms. I picked it because my mother-in-law was the crystallographer who determined the structure of tourmaline. So this one has a fond space in my heart. So this quote, taken from the 20th century theologian and geologist and paleontologist and Jesuit priest, Pierre Teilhard de Chardin, it's from his book, which was published posthumously, The Divine Milieu, and it captures for me in many ways what it means to do science as a spiritual practice, as prayer, and perhaps specifically as Lectio Divina, unpacking the code in which God has written creation. So by means of all created things, without exception, the divine assails us, penetrates us, and molds us. We imagine it as distant and inaccessible, whereas in fact we live steeped in its burning layers. In Eo Vivimus, as Jacob said, awakening from his dream, the world, this palpable world, which we were wont to treat with the boredom and disrespect with which we habitually regard places with no sacred association, in truth is a holy place, and we did not know it. Venite adoremus. And the picture here is from the roof of the Papal Palace outside of Rome in the Summer Gardens that belong to Vatican City State. And in fact, it says Venite adoremus. So that's on the wall of the telescope dome. Come adore. So this whole notion that science is somehow separate from our faith, here at the Vatican Observatory, it's crashing together. So I want to say that science is not a book of facts, and religion is not a book of rules. They are both human endeavors, ways of wrestling with the universe and our relationship to it. So as much as scientists would like to say we are objective, we are in fact part of the created universe, and we cannot completely separate ourselves from our science. So I might take Heisenberg and expand on Heisenberg's quote and add that natural science does not simply describe and explain nature. It's part of the interplay between nature and ourselves. It's also part of the interplay between God and ourselves. And I sometimes think about it's sort of God puzzling out things with us. Here's some clues, read these clues. And that draws us more deeply into the mystery that is creation and the mystery that is God. I'm going to take a step back and say a little bit about where I'm coming from as I talk about this. It's a little self-reflection. So I am a scientist and a Christian. I'm a practicing Roman Catholic. I would say I take a contemplative approach to my faith. I'm willing to spend time in silence. The longest stretch I've spent is 30 days. I'm a quantum mechanic, so I fix broken quantums, as you might guess from the slide there. And I use really huge supercomputers to kind of dig into the interior of molecules to find out what makes them tick. And my own spiritual practice kind of looks back to the wells of the 3rd and 4th century desert solitaries, Abba Poemen, Amma Synclectica, who struggles with distractions, attempts to balance a solitary life with hospitality, and the concomitant interruptions that are inherent to the working of teaching. So, an uninterrupted day for me is like an incredible gift. If I'm in my office, students are knocking at the door, colleagues are knocking at the door. How do you balance hospitality with the need to dig into the work? The Psalms were the spears that those contemplatives wielded with fervor and joy. And I would like to say that my prayer life is pretty anchored in those ancient poetic prayers. I'm part of an Augustinian community that meets every morning to celebrate the Liturgy of the Hours. But as a scientist, I find the Psalms an incredibly rich space because I'm caught again and again by the images of the created world that sit in those Psalms. The hoarfrost is scattered like ashes. Bees harass the unwary. And I still love this, the snails that trail their glimmering slime. All those are images right out of the Psalms. So I'm a theorist, which means that even though I show you pictures of me working in the laboratory, that's more what I do for teaching and less than I do for experimental work. Although when I wrote that book on tea, for the first time in about 30 years, I went back into the laboratory to do original experiments, much to the amusement of my colleagues. They're like, "You're doing actual experiments?" I'm like, "I am." But one of the joys of theory is that the constraints on the molecules you work with are a little different than those that experiment imposes. And they don't actually need to exist. Like, I can just make a molecule up out of my imagination and see what happens with it. So here's some of the molecules that I work with. One of them is the one in the middle is shaped like a Möbius strip. They're all molecules that in some way misbehave. And the real key is that the molecule doesn't know that it's misbehaving. It's only misbehaving as far as what chemists think it can do. So this, for me, is part of that interplay with the created world. Here's a puzzle. I think I know the answer, but in fact, this puzzle suggests I don't. How can I dig more deeply in to discover what God is saying to me? And I sort of think back to the Annunciation. So Mary says to Gabriel, "How can this be?" And God, through Gabriel, responds to her. And I ask when I face my science, "How can this be?" And God, through his creation, answers me back. And then I respond by thinking up a new molecule, and God, through the laws of nature, responds to me. It's a dialogue between me and the Creator, and in some ways I would say that's prayer. So I love this quote from Merton: "What I wear is pants, what I do is live, how I pray is breathe. What I wear is a lab coat, what I do is science, and how I pray is everything." And in or out of the lab, I am trusting that God is always present. So I want to say that this is not going to be really a philosophy talk or a science talk or a theology talk, except perhaps as theology is faith-seeking understanding. I want to make this a reflection on practice. What does it look like as a scientist to be a scientist of faith and have that on the table? So I'd like to frame the question in the following ways. How can science, our work in the laboratory of the field, be prayer? What, if anything, might contemplatives have to offer scientists practically? And what, if anything, might scientists have to offer contemplatives? So this is a two-way street. And again, I'm thinking about practical. What perspectives might each side have that would enrich the other approach? And I want to be careful in this to keep the door open to non-theists, to people who say they don't believe in God. And I also want to avoid collapsing science and religion and faith into a single entity. These are different approaches to looking and thinking about the world, and I don't want to put them together. I write a blog called Quantum Theology, which some people think is about, there is something called quantum theology, and they think it's about quantum theology, but it's really about my being a quantum mechanic and a theologian, and not about quantum theology. So I want to say that despite the common misconception, science and faith are not at war. and they can share space. So this is a photograph taken from the roof of the Papal Palace. You can see one of the domes of the telescopes. There are 2 telescopes on top of that palace. Neither of them are used for research anymore, but they still show you the heavens. I've been up there and seen Venus. I have seen Jupiter. I have seen the rings, and I've been left speechless. But you can also see the dome of St. Thomas of Villanova Church there, which is done by Bernini. It's exquisite. And here the 2 spaces share the horizon. So one notion is that there's no common ground. So my husband's a mathematician and loves this quote from St. Augustine: "A good Christian should beware mathematicians and any others who prophesy irreverently, lest they be ensnared by demons." And sometimes when the math is not going well, he wonders if it's being ensnared by demons. But Augustine is not referring here to what we would call mathematicians, but really he's thinking about people who are sort of, casting lots in the marketplace. But we tend to think that scientists are heretics, somehow ensnared by demons, and people of faith are crazy, believing in utterly unprovable things. So both sides sort of have this kind of misconception sometimes. But these people might be surprised that there are a lot of folks who would find this a odd thought. So here are some people in their laboratories. There's up in the upper left-hand corner is an IR spectroscopist, John Klassen. There is a piece from someone's lab notebook. There's someone who studies meteorites standing in front of a meteorite collection, organic synthetic chemist standing in her laboratory. So John Klassen has also just stepped down as the abbot of St. John's Abbey in Collegeville, Minnesota. And that is Elizabeth, who is formerly a Buddhist nun, but now an organic chemist. That's Gregor Mendel's lab notebook. He's an Augustinian monk and the father of modern genetics. That's Brother Guy Consolmagno, who's the director of the Vatican Observatory. There is another chemist that you might know and recognize. And I can tell that he's trained as a chemist because if you're in the laboratory and you don't have your lab coat on, there's a funny way you kind of lean over things so that you don't drape your clothes on the lab bench. And there he is doing exactly that. And there are all these other people, Sister Kathy Duffy, Sister Mary Kenneth Keller of the Sisters of Charity, who is one of the people who developed the computer language BASIC at Dartmouth. And one of the first women to get her PhD in computer science. There's Gaudí, who designed the beautiful basilica in Sagrada Familia in Barcelona. The math in there is gorgeous and elegant. I had to drag my husband out when we saw that. He just kept saying, "But look at that cat name." I'm like, they're closing, it's time to go. There's Roberta Busa, who worked on the project to index Thomas Aquinas' work, which is the basis for some of the digital humanities work that goes on now. All right, who else? There's Busa. All right. So Pope Paul VI, in closing Vatican II, this is in the middle of the space race, is addressing science directly here. We're all out for a walk in the universe, and we will most certainly bump into each other, people of faith, people of science, people dealing with theology, people dealing with quantum mechanics. We're all seeking the truth. And neither side should wear blinders so that we're unaware of other searchers of good faith, even if they're not what we might call faithful. And the Church thinks she has something to offer from her rich treasuries of experience, from the Scripture to the Desert Fathers and Mothers, to Hildegard of Bingen, who is herself a scientist, a chemist, an herbalist, to my astronomer colleagues at the Specula Vaticana. So as tempting as it is to think of science and religion in opposition, the ultimate battle between facts and faith, at their core, they are both ways in which humans grapple with the fundamental questions of existence. Why is there something instead of nothing? Why is there this particular universe? What are we doing in this universe? And how do we, individually and together, work with and within the tangible world? And I really love this end of this quote. For this purpose, without troubling your efforts, without dazzling brilliance, we come to offer you the light of our mysterious lamp, which is faith. And so he's making quite clear that we're on this journey together, and that we're not trying to burst in and say we have all the answers, but we're trying to say, here's our lamp, we're holding it up. What can we see together by the light of that lamp? So I want to be careful to avoid collapsing science and religion into a single entity, but they are not disconnected. And I would argue that even if you're not a theist, even if you don't believe in God, religion still serves a purpose vis-a-vis science. So Pope John Paul II, in a letter to Father George Coyne, who is then the director of the Vatican Observatory, said, "Science can purify religion from error and superstition, and religion can purify science from idolatry and false absolutes." So each side has something to offer the other. And these are not new ideas by any means. Science and faith are both about truth, and truth cannot contradict itself. If they seem at odds with one another, if what we see from the science and what we believe from our faith somehow seem to be contradictory, it's really just a demand to go deeper, that we need to push further to find out what is the truth, not to dig into our entrenched positions, but to dig into God, dig into the mystery. So here we see a quote from St. Thomas Aquinas: "The truth of our faith becomes a matter of ridicule among the infidels if any Catholic, not gifted with the necessary scientific learning, presents as dogma what scientific scrutiny shows to be false." There's a lovely quote from Augustine, which I didn't put in here, where Augustine says he's thinking about the other side of the earth. And he says that there's no way that anyone can be living in essentially what's now Australia, because in fact they would fall off, right? Because they would be upside down. Now, Augustine did not really understand about gravity and gravitational attraction and how that might work. He did not have the necessary learning. So much as Augustine forms a deep part of my faith, I don't listen to Augustine when he talks about people falling off the bottom of the earth. So I want to think a little bit about Lectio Divina. So it's a particular approach to prayer, which often involves taking a small piece of scripture, reading it slowly, carefully, and then sort of chewing over it. Some of the spiritual writers talk about chewing your spiritual cud like you're a cow. But it is to sit deeply and long with a particular piece of scripture and let it settle into your soul. And I want to say that maybe we can think about science in a similar way. So this is a photograph of the chapel at the Specula Vaticana, so the Vatican Observatory outpost in Rome. It is tiny. You see about half of it in the picture. There's, and when you put a bunch of people in there for mass, it's fascinating because typically it's all physicists with an occasional chemist. The priest in this case is, always a physicist or a chemist. It gives some very interesting homilies, gonna say. So I love this definition of contemplative prayer from Walter Burkhardt. It's a long, loving look at the real. But I would like to say that that's a really good description of science. Right? To do science is to spend a long time studying something. And scientists are really passionate about what they do. We are taking a long, loving look at the real, what's right in front of us. And the picture here is an experiment that's been going on for over 100 years. And it's studying this particularly tarry substance and how fast it drops. And it drops like once every 40 years. And someone's been handing this experiment on to the next generation to do it. The reason it's of interest is it has to do with the movement of glaciers. So people are interested in figuring out how glaciers might move in this very slow way. And so they're studying these drops of these viscous fluid. But someone's passionate enough about this to wait 40 years for the next drop to fall, and to hand it on to someone else who's willing to wait yet another 40 years for another drop to fall. These days you can actually, there's a webcam that you can go and watch it if you'd like for a while. That may be contemplative. And so, as I said, my chemistry research interests center on these molecules that misbehave. The structures and reactivity are in some ways, to chemists, unexpected. And so it's an area of research which demands that I look at what is actually there and accept what presents itself, not what I expect to see, not what I hope to see, not what the theory says I should see, since that might suggest I shouldn't be seeing it at all, but what's actually in front of me without prejudice. And exercises of this sort, of course, are very familiar to practitioners of many contemplative traditions. Consider, for example, St. Ignatius of Loyola's notion of indifference. All right, trial and joy, cries of recognition, surges of inspiration. St. Teresa of Lisieux sounds pretty similar to what we hear when we do scientific research. You know, there's that moment when you think the experiment is really going to work. When you figure it out finally, that cry of recognition, and you certainly embrace both trial and joy. My youngest son texted me this morning, just before this talk started, to say that his PhD defense has been scheduled for November 19th, 10:30 in the morning. But he, about 3 weeks ago, cracked the final bit of mathematics for his thesis, and the joy, right? He comes bounding up the stairs and says, "I got it." There is that surge of the heart. There's also a lot of trial, as you might imagine, in a PhD in mathematics. So if we look at the Catechism of the Catholic Church, it says prayer is the raising of one's mind and heart to God, or the requesting of good things from God. So that's St. John of Damascus. But it's the whole person who prays. That's what the Catechism says. And so I don't pray not as a scientist, right? I pray as a scientist because it is the whole person that prays. So that is me as mother, me as wife, me as teacher, me as writer, me as scientist, me as person of faith. So in prayer, not only do we call out to God, but God endlessly calls out to us and is ever enfolding us in mercy and drawing us closer in love. And the science is just one way that God draws people in, and it works particularly well for me. All right. So here's just a bunch of different examples of prayer, but I'm going to again focus again on this notion of Lectio Divina, a contemplative approach. So again, St. John of Damascus. The whole earth is a living icon of the face of God. And I'm going to say, I love this quote, and it turns out if you try to track it down, it's not a quote. Nobody has been able to find the source for this. It's just someone kind of put it in the mouth of St. John of Damascus, and it keeps reappearing. So I'm going to point out that even though I'm attributing this to St. John of Damascus, it's really not necessarily him. But he did think this way. So to do science, to think deeply about the universe, is in fact to contemplate it. So maybe one question to ask is, are scientists really mystics? And are mystics really scientists? And if you pose this question to a bunch of mystics, if you go to a monastic community and give a talk about science, which occasionally I've done, and you say that, the other side kind of bristles, like, we're not scientists. And if you say that to scientists, they're like, we're not mystics. We believe in the real. But mystics are facing the real. So here's St. Anthony the Great. My book is the nature of created things, and as often as I have mind to read the words of God, they are at my hand. I will point out that St. Anthony in this painting is wearing a pair of reading glasses. When St. Anthony lived, there were no reading glasses. And St. Anthony the Great lived a very simple life, so I think the robes are probably also a little bit not St. Anthony's thing. But the painting is from the 15th century, so you get the reading glasses and you get the nice robes. But this is about decoding the universe, right? God has written into what we see around us his own image. And it's up to us to figure out how to decode it, uncode it, read the code. And so here is St. Teresa of Avila. Know that even when you are in the kitchen, our Lord moves amidst the pots and the pans. She said this because her sisters were annoyed that she was having ecstatic experiences in the kitchen. Like she was having mystical experiences of God in the kitchen. And they felt like, you should be having those in the church, sister. You should not be having those in the kitchen. But she's like, nope, the Lord is here amongst the pots and the pans, something I think about when I'm scrubbing them out at night. But I also think, then why is not the lab or the field site also a space to experience God? Our Lord moves there as well. And so now I've changed it, right? Even when you're in the laboratory amidst the beakers and the flasks, and I would say even within my computer. So here's some practical advice from the impractical. So I'm going to start with what might contemplative traditions have to say to us about what we do in the science. So there's three things, and I'm going to talk really about two of them. So an awareness of multiple dimensions, a non-judgmental view, okay, an unforced pace. So the photograph is, you can see Nakamura-san's hand in there. He's a scientist turned hermit and artist. He lives up in the hills in Japan. The way you get, I'm going to say really the mountain, the way you get there is to walk 2 miles up the mountain. And he will make you a cup of tea and talk to you about, art and science and faith and what it's like to live alone in the silence. He built by hand the stove that teapot is sitting upon. I took students up there, and he at one point sent a student off to light the fire, and my student had no idea she thought, teapots, you turn the stove on. So she was a little perplexed. But, one match and we did it. So how can we have a comfort with multiple readings of things? Chemist and philosopher Michael Polanyi summed this up, I think, well. We know more than we can say, right? If we think about mystical experiences, they're ineffable, they're indescribable, but there's always, a scientist needs to recognize that there's often more to the phenomena that we are observing than we can quantify. And that things that we can see and touch are a portal into things we cannot see and touch, and which we sometimes lack the words to describe. So many of you might have had a cup of coffee or tea before you came in here, or might have one now. I would encourage you to look into a cup of tea or coffee, or even a cup of water, and realize there are as many molecules in there as there are stars in the universe. So just within that cup, there are as many molecules as there are stars in the universe. And to think about, what does that mean? How do I wrap my head around that kind of almost infinity resting in my hands? So the things that we can see and touch, the water that I can, pour down the sink, is a portal into things I cannot see and touch. And at some level, modern science has kind of stripped itself of the words we need to describe. And if we can't give it a number, we say if it can't be measured, maybe it's not really science. But if you read back through the chemical literature, like if you read back 100 years ago, people were talking about the smells of their molecules. This molecule smells like a wet dog, someone wrote. And if you've ever experienced the smell of a wet dog, that's really vivid, right? You know what that smells like. And they would also sometimes report the taste of a compound. And of course now the thought of dipping my finger into some new molecule I've synthesized and tasting it, no way. But in fact, we used to be more hands-on into our work. But we've now gotten so hands-off in some ways that there's a recent paper about ionones, which are a compound that smells like violets. They're present in tea. They're used as perfume components. Nowhere in the article, which is about a molecule that smells, do the authors ever use the word smell. Never. And it's only on page 120 of the supplementary information that's included with this paper that the authors directly acknowledge that anyone ever actually smelled the compounds. Scientists need to stop and smell the flowers, is what I'm going to say. And the picture there is a picture of a meteorite that fell in France in 1492. It's part of the collection that's at the Vatican Observatory. It's about 4.5 billion years old. So if you think and look at that, 4.5 billion years old, and it was once in outer space, and now it's sitting on the desk. Again, how do we wrap our minds around these things? But we must do this. So in his book, Encounters in Silence, Karl Rahner reflects, if there's any path at all on which I can approach you, it must lead through the middle of my very ordinary daily life. So I want to think about dust. I think about dust periodically because, I dust my desk, I dust stuff at home, and dust seems pretty unremarkable, right? What's in dust? But in fact, there's a lot to be found in dust. I think the next picture. So this is a poet Marilyn Nelson, and the poem is called Dusting. And this is just a piece of it. Thank you for these tiny particles of ocean salt, pearl-necked viruses, winged protozoans for the intricate shapes of submicroscopic living things. I'm going to say that that's what's in dust. We think of dust, again, as being something that we just want to get rid of. But in fact, there is a lot hiding in dust. This is hiding in dust. So these are micrometeorites, and this is from a wonderful book by John Larson, In Search of Stardust. But if you pull the dust from the top of a building and look at it under a microscope, these are some of the things you would see. Can you imagine that's what's in dust? It's really hard for me to imagine what's in dust. But there's tiny tokens of the universe that have settled onto our roofs, onto our plants. If I were to pull up something from my desk, I expect to find fragments brushed from the cliffs I hiked in Ireland, coral blown into the air by storms in the Pacific, and burnt off comets that blundered into Earth's atmosphere. Crumbs of the infinite lie scattered across our desks, across every surface we touch. It makes me hesitant to pick up a dust rag and wipe it away, but you know, it's a good excuse for not dusting. So the second piece is to think about not only these multiple readings, how do we see dust as both this incredibly rich source of information about the universe, this incredible beauty that's hidden within it, how do we think about the infinity that's in our cups of water, multiple readings. The contemplatives are not bothered by this. There are multiple ways to look at the universe, and one can just sit with it. But I also want to think about having a non-judgmental view of the universe. Again, paying attention. Attention is the rarest and purest form of generosity. And the truth for us is written in the details. So Robert Boyle, who was one of the early chemists, and that moment shifting from alchemy to chemistry, was a vocal champion that you should do research not quietly, privately in your laboratory, but in the presence of an illustrious assembly. He thought the only way you could really prove that your experiment worked is to have everyone sitting there watching you do it. And in fact, he wanted you to have like witnesses sign off on it. But that soon became pretty impractical. Like you can't like tell someone in Germany what's happening in England if you have to like get everyone to come on a boat from Germany to England. So in the end, he said we should use vivid descriptions and rich illustrations. And in those, you should include the circumstantial details that create the illusion that you're present. So as abstract as scientific work can be, we always experience it first as something concrete, something particular. We work not with the schematics, but with the actual instruments, computer codes, and materials. And we need to have, in the middle of this, an appreciation of the particulars, to have an eye for detail, what St. Ignatius of Loyola might call the composition of place. So to bring all of our senses together, even the ones that we think may not apply, to do that. When I was first working as a graduate student, I used to track the progress of my calculations on the computer by listening to how fast the disk drives were spinning. So when it hit a particular part where it had to like read in a bunch of integrals, the disk would almost scream. And I could hear, I think, it's hit that part, and so when it hits that part, I finished one step. When it hits that part again, it should be done, and then I would get up and check my results. So I was using my ears to process what was happening with what was going on the computer, which you would think, I don't listen to the computer. Well, I guess these days we do listen a lot to the computer, right? Hey, Siri. Sorry, I summoned Siri by saying her name. Go away, Siri.
Do that in the contact.
All right, here we go. But 1,000 years earlier, Bessarion, one of the Desert Fathers, had a saying for his monks: a monk ought to be like the cherubims and seraphim, all eye. Scientists need to be like the cherubim and seraphim, all eye, and I would argue all ears, and a willingness to, perhaps, if safely can be done, smell and taste. So the next piece I want to take as advice from the contemplatives to scientists is to think about an unforced pace. If we think about how life goes these days, life goes fast. And the monks would say, maybe we need to slow down. So we tend to think of science as fast and frantic, and now you all know I'm a Trekkie. So we're invested not just in publishing our results, but in publishing them quickly. So the Journal of the American Chemical Society now has an online section called ASAP, as soon as possible, and they promise that the work you do will be posted within 24 hours of the editor signing off on it, which is crazy, right? I mean, it used to be it took months for work to appear. I just signed off on an essay for Nature where I got it in the morning and I got proofs back in the afternoon, and then I put comments on that and it'll show up on Monday. Does it have to be so fast? It's not clear that a fast pace is as productive of science as we think. Historian of science Gerald Holden notes that key developments in science often depended on an unforced pace of work, and that's a skill that contemplatives have in full measure. And I would like to suggest that maybe some advice we could take from contemplatives is to see science as more than a series of competitions with heart-stopping races to an arbitrary finish line, but also to learn to value slow science, where the pace is driven by the needs of the work, not the need to find an answer ASAP. So I'd like to invite you to look at this for a minute and tell me what you see. What do you think those people are doing? It looks like they're reading their phones, doesn't it? This is from the Met in New York, and I saw this and I had to take a picture because what it looked to me is like my students, right? When I look out at a class before class starts, they're all looking down at their phones texting. How can we bring this willingness to wait into science? So we want to slow things down. And contemporary monastics know how to wait. So in 2005, the documentary film Into Great Silence by Philip Gröning was released. And Gröning had written to the monastery in 1984. Okay, so the film was released in 2005. But he wrote in 1984 asking permission to make the film. So this film is about a year in the life of a Carthusian monastery. It has no soundtrack other than the ambient sounds of the monastery in it. It's an extraordinary and exquisite film. And Gröning and one cameraman spent a year living in one of the hermitages within the monastery to make it. But he asked the community to do this, and they said, we need a little time to consider the request. They needed 16 years. And 16 years later, they wrote and said he was welcome to come join them. So scientists, those who work on space probes, are interested in materials that change in a very long time scale know how to wait. But even when the time scale doesn't dictate that, the reward for slowing down can be pretty substantial. And I want to show one example of this. So this is in early November of 1895, while experimenting with fluorescence produced by a Crookes tube. William Röntgen, a physicist, noted that a surface coated with a fluorescent salt glowed whenever the tube was discharged. And he did some experimenting. He stopped his work and he just played around with it. And he said, I didn't think, I just investigated, I just looked. And what he figured out in a couple of weeks of playing around were there were some unknown rays being generated, and he called them X-rays, and we still call them X-rays. He called them X-rays because he didn't know what they were. And he found that when he waved a hand between the source and the screen, he could see the shadows of his bones. And he spent 7 weeks playing around and finally making a report about it. And then the next thing you know, this was all over the newspapers. There were photographs. This is his wife's hand with the wedding ring on it. And shortly thereafter, people were using this in clinical practice. It made a huge change. But this is not the first X-ray. That's a Crookes tube, which is kind of a pretty thing to say. So 5 years previous, in 1890, two physicists at the University of Pennsylvania were also playing around with Crookes tube. And they packed up their stuff at the end of the night and took it home. And it was kind of a rainy night in Philadelphia. It was February, so it was cold, and they didn't pay a lot of attention when they were cleaning up, and one of them failed to notice which stack was the exposed plates they'd been playing with, the exposed photographic plates, and which ones were not. So the next day he just developed them all. And one of them had this weird image on it, and they couldn't figure it out. And he and his fellow physicist exchanged a few, in those days it was telegrams, right now it would be an email. But they exchanged a few telegrams trying to figure out what happened, but after 3 or 4 days they just kind of gave it up. What they had was the first X-ray. That's the trolley fare sitting on top of the photographic plates. And the X-rays from the Crookes tube created an image of the trolley fare sitting on top of the plates. This is the first X-ray image. But their rush to try to figure it out also led to their failure to see it for what it was. So they had discovered X-rays almost 5 years before Roentgen had, but didn't know it. So that's maybe some things that contemplatives have to offer scientists, but do scientists have something to offer in return? And I'm going to say yes. This is a photograph from the doors at St. Thomas of Villanova in Castle Gandolfo. What do you see on there? You see a molecule. It's a pretty famous molecule. It is DNA. It's also the wrong-handed DNA. And I can explain how that came to be if anyone's interested. But what I want to say, what people of faith can get from scientists are maybe 3 things: that there's beauty in the strange, that doubt is not the enemy, and that you can live with uncertainty. So this is from Edward Purcell, who won the Nobel Prize for his physics of NMR, and if you don't, nuclear magnetic resonance, if that's unfamiliar to you, it may be more familiar to you as MRI, magnetic resonance imaging. They're the same thing. But I love this notion that he has of, I've not yet lost a feeling of wonder and of delight, that the delicate motion should reside in all ordinary things around us. I remember in the winter of our first experiments just 7 years ago, looking on snow with new eyes. So it's possible to have awe in the face of our science. There's beauty in things, and you might need to learn to see the beauty in a different way. So these are my top 10 most beautiful molecules. And again, just like chemists are afraid to use the word smell, we're also afraid to use the word beauty. The physicists are not afraid of beauty, but somehow the chemists are afraid of beauty. So here are 10 molecules that I thought were beautiful, and I have a whole essay describing on why. But again, we need to look more deeply. If you're not a chemist and you look at these molecules, you're like, what are they? There is caffeine is up there, which is a molecule that may be near and dear to many of our hearts. There is insulin, there is penicillin. There's molecules that are just beautiful for their color. In the upper left-hand corner is azulene, which is a gorgeous kind of purple-blue color, very unusual for an organic molecule. There's beauty in the strange. What we don't know, that doubt is not a bug. Doubt is a feature. That doubt is what drives us, it's what draws us in, right? Here is doubting Thomas, right? And we kind of think about Thomas as, he's the one who doubted, other people believed. But in fact, doubt drew people in. It led him to want to get closer to Christ. And doubt can draw us in too. So this is Brother Guy Consolmagno again, and his famous thing about, what kinds of questions are interesting in science. There are questions that draw you in more deeply, and then there are questions that are just yes or no. Is there enough money in your pocket for a gelato? And Guy is a big gelato fan. So in this case, as you can see, there was money enough in somebody's pocket for gelato that day. But that's not the kind of question that really draws us in. It's yes or no, and if there is, great, and if not, then we just move on. But it's the questions that draw us in. So here's a picture, and it's of my niece's hands. And we were staying at my dad's in Central California. He lived off a dirt road, off another dirt road, very remote. And my niece lived in the farm next door, and she comes over and she says, "There's something wrong with the sun." And you're thinking, what's wrong with the sun? She says, "There's just something funny about the sky." And my first thought is there's a fire and we're going to have to evacuate. And how I'm going to get my dad, who's frail, and his wife, who's frail, how are we going to get everyone out, the dogs, what are we going to do with the sheep? I don't know. And so I go out expecting to see smoke in the sky. But in fact, my niece is right. There is something funny with the sky. There is something wrong with the sun. We're having a partial eclipse. And I didn't know it because it wasn't going to happen on the East Coast, and I was out visiting the West Coast, and I had, in fact, been staying in a monastery up in Big Sur for a week, so I hadn't read the newspaper either. So I had no idea this eclipse was coming, and it actually turned out neither did my dad. And if you hold your hands up like that, you can see the little curves of the sun. And so we held our hands together, and I'm like, this is an eclipse. We're having an eclipse. So this, willingness to ask the deeper questions, to say, something looks funny, the sky looks funny, what's going on? So doubt is not the opposite of faith, it is just one element of faith. It's something that can draw us more deeply in, and we should not fear it, and that's something we can learn from scientists. Not everything is knowable. And so you might be at home with the Heisenbergs. If you're not a physicist or a chemist, you might not know what the joke is here. But the Heisenberg uncertainty principle says you can't simultaneously know exactly where something is and where it's moving. And it's somewhat more complicated than that. And I have a T-shirt that has the whole shebang on it, which I wore to the beach with a bunch of humanities friends, one of whom looked at it and it says on the back, "Don't ask me, I'm uncertain too." Which again, if you're a physicist and you recognize the equations on the front, you think this is pretty funny. But one of the humanists looked at it and said, yeah, I don't understand math either. So, one marker of mystical experiences is that they are indescribable, ineffable. And there are some things we cannot know. Like, I know where this podium is, right? It is right here and in front of me. I know where all of you are. I've never seen an electron, but I am convinced that they exist. And I'm willing to see their tracks and willing to live with, I can't know exactly where they are. No matter how good my experiment is, no matter how good my equipment is, I can never exactly locate an electron, and I must live with that and that uncertainty. And we need to be able to live within that uncertainty with God as well. We know more than we can say. So what can contemplatives learn from science? To find beauty in the difficult, comfort with doubt, and to live with uncertainty. So I want to finish by saying that for all that I'm engaged with science, I'm here with Karl Rahner to say that to be able to stammer about God is more important than to be able to speak exactly about the world. So as much as I would like you to know all the quantum mechanics that I do, and I did promise one of the students, I think, that there would be quantum mechanics, there it is. Indeed, in the end, we come from God and we go to God, and all of these things are simply ways to find our way more closely to the divine that's created us. And so I hope that we can find the mesh between poetry and between science. We live in a universe gone wild with light, and we long for light. We long to be immersed in it, to grasp its nuances and vagaries with whatever tools we have to hand, whether they're prayer or quantum mechanics as prayer. And I'd like to leave us all with a bit of a blessing, which comes from this same poem by John O'Donohue, Matins. So may you live this day compassionate of heart, clear in word, gracious in awareness, courageous in thought, generous in love, and all in a universe gone wild with light. Amen. And I'd like to say thank you. And those are all the people I should thank. Thank you. And thank you all for your attention. Do we get to ask questions? I didn't ask this part. Yes.
Actually, I have microphones.
Oh,
that I can
perfect.
We can all hear the question.
Okay.
Very interesting.
Thank you.
I would have thought somewhere in there there'd be a mention of the Da Vinci Code. So what do you think of Dan Brown and Angels and Demons?
All right, I've read it. It's a sore spot at the observatory, I'm going to say. The movie opens with a Jesuit brother with a big beard, and if you look at Guy's a Jesuit brother with a big beard who works at the Vatican Observatory. There's a scene which is supposedly in the library of the Vatican Observatory, which is where my office is when I go, which looks nothing like that. It's much fancier in the movie than it is in real life. So I guess I would say, so if you're a Dan Brown fan, sorry, I'm not particularly a Dan Brown fan. But anything I think that gets people thinking about, doubt and mystery is an okay thing. But I'm personally not a fan.
Anyone else? Yeah.
There was a book by Gerhard Schrader called Genesis and the Big Bang. Perhaps
Yeah.
you've read it, in which he tries to reconcile the account of Genesis 1, with the newest research in cosmology. So, of course, according to Genesis 1, God creates the heaven and earth in 7 days. But, according to the astronomers, the Big Bang occurred 13.8 billion years ago. And he tries to reconcile these two using Einsteinian reference frames. And of course, the reference frame of God is different from the reference frame of mankind. But I'm curious, do you feel that it's necessary to reconcile the two accounts so we can just hold them as two separate truths in our mind?
I think I hold them as two separate truths. I don't feel the need to find a way to make Genesis map perfectly onto what we currently understand about cosmology. I mean, Genesis is trying to tell us something about who created the heavens and the earth, but it's not necessarily trying to tell us how. And cosmology is really thinking about how is that happening in detail. But it offers us a space to think. So I sometimes think about, the first moments of after the Big Bang, when the universe was like the size of a grapefruit and dark, right? It really didn't burst into light for some time. What was that like? And that gives us kind of a way of thinking about God's connection to it, but I don't feel the need to map it directly on. I'll offer another thing. If you're contemplating your cup of tea or coffee, that the part of the water in there is 13.8 billion years old. It was about 1 second after the Big Bang those protons were created. So your water is really old.
We have time for perhaps one or two more questions, if there are others.
I think behind you? Somewhere behind.
So I recently learned about the Higgs boson particle and how it kind of brings up the philosophical question of if our universe is ordered or if it's chaotic, and I was just wondering what your thoughts are on that.
So I think that there is both order and chaos. To me, in some ways, the existence of evil suggests that there is chaos, right? That there are things that we do not control that do not end in the way we would like them to end. But I think that order is also something that we deeply desire because we desire the predictability of it. So I think order and chaos both play a role in all of this. And yeah, the Higgs boson is an interesting space to think about that.
Hi, so I'm one of those humanities majors who doesn't understand science.
That's okay.
But what I was going to ask is, I know you're involved in like quantum mechanics, and I'm familiar with like the double slit experiment.
Mm-hmm.
Do you think the idea that like there's an observer and that changes the way particles move might imply something about there being a God, or something about observation being like a fundamental part of the universe?
Right, yes. So if you don't know what the double slit experiment is if you direct like particles at a slit, you will get a interference pattern as if there were waves, and you get it even if there's one, which is a really weird, quantum mechanics is very weird. I'm not sure that it necessarily proves the existence of God, or it might suggest the existence of God in that sense, of that an observer needs to be present for the universe to kind of work in the way that we see it work. But I'm always hesitant when someone says, oh, there's physics that definitely proves God. Because I think that, physics is what we know right now, but there's clearly way more questions that we have that are not answered and may be answerable. So.
We have one more question, but you're obviously free to stay and speak with Dr. Frankel afterwards.
Hi, I was wondering, do you ever have the opportunity to speak to students?
I do. I speak to students like 4 times a week.
I know that you're
Yeah,
a
I
teacher and
teach.
your profession is the chemistry, but do you combine the two in any kind of classroom
Generally not. I mean, generally I teach, quantum mechanics, introductory chemistry, molecular structure, those sorts of things. I do a lot of writing on the side where the stuff is more likely to show up, and occasionally I've taught a course on the history of contemplation in the West as part of the college's 360 program, but yeah, no, but students know. They show up in my office. A student showed up in my office last week, and she made an appointment. She says, I know that I found your blog. I know you write about science and faith, and I want to talk about it. And to which I said, yes.
Gotcha. I just didn't know if the two were exclusionary in the classroom or if you've had the opportunity at some point to do that, but I see that's how you're doing it.
Yeah, that's my choice about how to do it. Yeah.
Got it.
On behalf of Father Brian Kuhl and our Catholic Newman community, we'd really like to thank you for coming out and to our lecture this morning with Dr. Frankel. We'd also like to thank Reverend Denise Yarborough and the Interfaith Chapel for co-sponsoring our event, and especially for Dr. Michelle Frankel for her being with us this morning. Thank you, Doctor.
Well, thank you.
There is coffee outside if you'd like another cup to the left.
There we go. Yes.
I found your talk absolutely brilliant.
Oh, thank you.
Marvelous.
Thank you.
But not sufficiently schooled in this zone, but working my way there. I worked on the lunar module, and I went into space law, and
very
so
cool.
on.
Very cool.
And I found your remarks really, really wonderful.
Thank
Not
you.
just brilliant, but nourishing.
That would be my hope, actually, is that people find
They
something
try
in
and
them.
reach you